This is example number 11 or 12. What is the number? Okay, I am writing this to be 11. Example number, so 11. Okay, so write the statement of the example. A certain particle has a lifetime of 10 raised to minus 7 seconds when measured at rest. This is the information given. How far does it go? How far does it go before decaying? If its speed is 0.99 c, okay, not c, but it is 0.99 c velocity of light when it is created. Okay, so we have to calculate this. Now, as usual, solution. So the first statement, what gives you is that it gives you proper time. So lifetime of that particle, elementary particle, is measured at rest. That means the measurement, observer and that particle are in the same frame. So that is the proper time. So right here, the given proper time is t prime is equal to 10 raised to minus 7 seconds. Okay, and as we know, the time dilation relation is, okay, so it is given by, we have to measure this t is equal to t prime divided by square root of 1 minus v square upon c square. Now it's a simple calculation. Just replace the numbers. T prime is given to be 10 raised to minus 7 seconds. V is given to be 0.99 c. Therefore calculate t. Therefore t is equal to 10 raised to minus 7 divided by square root of 1 minus 0.99 into 0.99 c square divided by c square again. So just calculate this. 10 raised to minus 7 the numerator divided by square root of 1 minus. Now see this calculation. It gives you c square get cancelled, and find the product of 0.999 into 0.99. You will get something very interesting. That comes to be 0.98. Check करा calculator वरती or on your mobile too. So this is 10 raised to minus 7 divided by 1 minus 0.02. Now get its square root and you will get this number to be, I am just directly taking this, it is now this time 7.088 into 10 raised to minus 7 seconds. Try to understand, in its own frame of reference this particle lives for 10 raised to minus 7 seconds before decay, whereas if it is measured by observer in frame K, okay, now he will find the lifeline or lifetime of that particle will be some more, that is 7.088 into 10 raised to minus second. So it is lifetime is extended, that is time dilation, because of time dilation effect this life has been extended. And therefore now next is the distance traveled. The distance traveled before decay is, okay, again this description is from K, frame K, second frame of reference, stationary frame of reference. This is from K, and this is, it's a simple calculation. Distance traveled is a product of velocity into its lifetime t. So I know v is 0.99 c into t is obtained to be 7.088 into 10 raised to minus 7 second. Second can cancel here. So these numbers get 0.99, c is 3 into 10 raised to 8 meters per second into 7.088 into 10 raised to minus 7 seconds, and you will get answer. I'll just give 1 minute to you, just calculate this. This calculation gives, now this is 10 raised to 8, 10 raised to minus 7, that gives you 10 raised to 1, and I can write this to be 9.9, that is approximately 10. 10 into 3 is 30, 30 into 7 is around 210, something more. So this answer, okay, no need to calculate by calculator, this comes around, exact answer is 211 meters. Okay, I don't need a calculator here. 10 raised to minus 8, sorry, plus 8, 10 raised to minus 7, that gives you 10 raised to plus 1. So 30 or 9.9, 9.9 is as good as 10, 10 into 3 is 30, 30 into 7 is 210, and because of all that fractions etc, this is more than 210, and it exactly comes to be 211 meters. Or you can by calculator, this will be some fraction will be possible there. So you will now see in its own frame of reference the distance traveled by that particle will be a bit different, so you have to get a product of v into t prime, whereas in the same particle that is being observed by observer in frame K, stationary frame, it will travel this distance to be 211 meters. Now same calculation I can do there in its own frame of reference. This is v into t prime, so it is 0.99 into 3 into 10 raised to plus 8 into this time is given to be 10 raised to minus 7 seconds. So just do this calculation. So this 8 and 10 is plus 1, and this is 10 into 3, actually it is 9 into 3 is 27, 2 will be there, and this is 29.7 meters. Okay, so this is very short distance in its own frame of reference, that is 29.7 meters, whereas this actual distance measured by an observer in frame K will be 211 meters. So that length contraction occurs because of that relative motion of that particle with respect to the first frame. So that is the difference one has to understand here. Now next two are theoretical questions. We'll go for this. Actually we have not discussed this earlier in our discussion, but here we are going to show as follows. Okay, now example number 13. So write the statement. Show that this is again one of the very interesting question, very many times it has been asked examination. show that the relativistic energy I'm sure you are finding my handwriting is now becoming not good one, but I have made some practice to write all these things a lot many times. That's when I'm able to write this in a good way. So this E is to be obtained to be root of P square C square plus M0 square C raised to 4. Okay, where the small p is momentum of the body. Small p is the momentum of the body. Actually, it's very simple derivation. Only we have to understand how it comes, why it is this way, why to write it in this way. Okay, let's start. We have to go for first formula for relativistic mass. Okay, the relativistic mass is given by m is equal to m0, that is rest mass, square root of 1 minus v square upon c square. Okay, now it's very simple algebra. Squaring both sides of equation. Actually, we are just doing mathematics here. So that gives me m square is equal to, this is m0 square divided by 1 minus v square upon c square. Right hand side can be, now this is c square minus v square upon c square. This c square can be taken in the numerator, so it becomes m0 c square divided by, now this is c square minus v square, rearrangement. Using this, I can take this c square minus v square on the left hand side, so it becomes, the next is m square c square minus m square v square is equal to m0 c square. Now next step is, this board has stuck. Okay, I'm going somewhere else. So multiply both sides by c square. Okay, multiply both sides by c square. So each term will be multiplied by c square. So we'll get m square c raised to 4th minus m square v square c square is equal to m0 into c raised to 4th. So I'll write m square c raised to 4 is equal to, the second term I will take on the right hand side, so it becomes positive, m square v square c square plus m0 c raised to 4th. M0 square is there. And remember this, the quantity on left hand side, the quantity on LHS is, if you remember, it is actually square of relativistic energy. If you remember, we have already written that E is equal to mc square. So therefore E square will be m square c4. Earlier we have seen several times this type of derivation relation. And remember here, in the second term, this product mass into velocity square, mass square into velocity square. So this mv is called as momentum, and therefore m square v square will be simply p square. So I can replace the quantities here. Therefore E square is equal to, this is p square c square plus m0 square c raised to 4, and taking square root you will get E is equal to square root of p square c square plus m0 square c raised to 4, and this is what our derivation. Remember, lot many times this also has been asked for 4 marks, so be careful regarding this. Very simple derivation. Start from relativistic mass, make square, readjust the terms, multiply by c squares, and identify what each term represents. Then it makes simple for you to find out this relationship. This is one of the very fundamental and important relationship used in relativity as well as in general theory of relativity. Almost in every branch of physics, in quantum mechanics also you will find this relation comes lot many times. It's one of the very useful. In the advanced study you will understand more about this, so not to go for this. Now 14th example number 14th असाच प्रॉब्लेम है. show that the rest mass of a particle of momentum p is the symbol for momentum, and kinetic energy t, write kinetic energy explicitly. Kinetic energy T, capital T, is given by. So again, this is theoretical one. m0 is equal to p square c square minus t square divided by twice tc square. So you have to use the upper relation there. E square is equal to p square c square plus m0 c square into m0 square c raised to 4. This relationship we have to use here in the formula. Okay. Now for that we have to go for earlier derivations of energy. E is equal to mc square. Remember that derivation. We come across this relation earlier. Okay. The relativistic energy is given by. Energy is given by. Okay. Now this is, if you remember, just try. This is relativistic energy E. It is Ek kinetic plus E0, that is the rest mass energy. I don't know how many of you remembering this. Almost before 1 week we have seen this derivation. E is equal to Ek plus E0. We have been given Ek in this case is T, so I can write capital E is equal to T, that is kinetic energy, plus I is E0. E0 is rest mass energy, so it is given by simply rest mass is m0 into c square. Okay, and also we have a relation we have just now written. E square is equal to p square c square plus m0 square c raised to 4. Okay, call this to be equation 1. This is equation 1 and this is equation 2. Now square equation 1 and substitute here. So squaring equation 1 will get E square is equal to, now this is a plus b square, so this is t square plus m0 square, sorry, this is m0 square c raised to 4th plus twice T m0 into c square. So this is a product. A plus b square is equal to a square plus b square plus twice eb. I'm using this. Now this left hand side of e square can be replaced by this 2. So substituting, spelling is not correct, substituting e square from equation 2. So right here it is t square plus m0 c raised to 4th plus twice t m0 into c raised to 2, okay, not 4, 2 is equal to p square c square plus m0 square into c raised to 4th. This is m0 square, m0 square c raised to 4th twice t m0 into c raised to 2 is equal to this. Now look, what is cancelling? So this term here m0 square c raised to 4th, m0 square c raised to 4th is cancelling. This t square can be taken on the right hand side. Therefore what remains on left hand side is twice t m0 c raised to 2 is equal to p square c square minus t only, and therefore a rest mass is m0 is equal to p square c square minus t upon here twice t into c square. This is what answer. So look at this example number 11, 12 and 13. What we have solved, all these 3 examples are important from the examination point of view. So you can go for, this is actually solved in the textbook, but we should understand there can be several such type of mathematical relations can be obtained in special theory of relativity, which connects rest mass with the momentum, momentum with the kinetic energy with some other physical quantities, and like that several types of such relations can be obtained. So go for any standard reference books, you'll find out there can be several such type of relations are available or possible. And remember, every relation or this type of equation has some applications, some or other applications in physics as well as in other branches of sciences too. So here we have solved almost 13-14 problems from the solved sections. Now 2 more problems I would like to get from this unsolved section, example number 9, but in our list this problem comes to be problem number 14. Simple one, 2 very simple problems we'll solve, and then we'll go for the next, that is assignment. Problem number 14, one line statement is the total energy of particle, the total energy of particle is exactly twice of its rest energy. Total energy of the particle is exactly twice of its rest energy. Calculate its speed. Calculate its speed. Now remember, solution. Total energy is given by E is equal to mc square. Okay, and we have been given this total energy is is 2 times actually we should use that which formula we have to use, 2 times of rest mass energy. That is m0 c square. Now look at what we have been asked. तुम्हाला काय विचारले बघा. I can use वरचे मला फॉर्म्युले वापरता येतील. Not this or this type of formula I can think about. ठीक है ना, m0 square c4 p square c square and this total energy is given by, it's not coming down, yeah, this is relativistic energy. Either it can be given by this relationship or we can see here is equal to m square mc square, and so total energy, can anyone guess? Total energy of particle exactly twice of its rest mass energy. So actually I have this energy to be equal to E is equal to we cannot write this way, okay? That means twice of, in this relation there should be somewhere V should become, जे V कुठेतरी ह्या रिलेशन मध्ये यायला पाहिजे. So where it comes, I think this relationship we have E square is equal to P square C square plus M0 square C raised to 4th. Okay, this P is nothing but M square V square into C square is equal to M0 square C raised to 4th, and left hand side is E square, and we have been given this E square is twice of rest mass energy. So I can here, since E square is twice of m0 times c raised to 2, okay, that E is good. E is equal to twice m0 c square, therefore E square is equal to 4 times m0 square c4. Substitute that in our equation, therefore we will get 4 times m0 c raised to 4th is equal to m square v square into c square plus m0 square c raised to 4th. So one of this will get cancelled, we will get 3 m0 c raised to 4th is equal to, I can write here to be m square board is not working sometimes, so v square into c square. Now again this m square can be replaced by m0 square upon root of 1 minus v, sorry, this m can be replaced by m0 upon root of 1 minus v square upon c square. So this gives you 3 m0, is it square? Yes, this is square. It is square asnar. Yeah, 3 m0 square c raised to 4 is equal to m0 square into v square into c square upon 1 minus v v square upon c square. Now solve this. So solving, I'll just write it here. तुम्ही खाली लिहू शकता त्याच्यामध्ये. This is इथं मी घेऊ शकतो. This is c square minus v square. So it is further I'm writing it here. इथं असेल 3m0 square का जो square c raised to 4th is equal to m0 square v square c raised to now 4th because of this c square in the denominator, right? C square minus v square, and therefore 3m0 square c raised to 6th minus 3m0 square c square, sorry, c raised to 4th into v square is equal to m0 square v square c raised to 4th. Now look at this, m0 square c raised to 4th v square, that is this relationship. So you can take this quantity on the left hand side or this on the right hand side. So that becomes 4 times m0 square v square into c raised to 4th is equal to 3 times m0 square. Net connection is breaking right here. This is 3 m0 square and c raised to 6th. So here m0 square gets cancelled. This is c square on the left hand side, so it is 4 times v square is equal to c raised to 2, and therefore v square is equal to c square upon 4, and therefore finally v is equal to c upon 2, 1.5 into 10 raised to 8